Hello guys, welcome to my channel and like continuing from the last week's video and about this series about best practices in writing the best smart contracts. So here in this video I'll be talking about gas optimization, which is quite important because the way we write our smart contracts, the way we arrange the variables, the storage, memory, or the functions itself or the loops, so how they affect the gas upon the deployment of the smart contracts or during the transaction. So what are the things that we can avoid and what things that we should implement in our smart contracts. So that's what we are going to discuss today. So first of all, we need to know what is gas optimization. So we all know that for any transaction on the Ethereum blockchain, we need to spend some gas because Ethereum is a, how do you say, internet of financial internet, I would say. So you need to spend gas for any transaction. So gas optimization is the practice of avoiding the ways that increase the gas cost on EVM blockchain. So what practices would increase gas cost, or what are the expensive practices that usually people developers might do? So first of all is read and writing state variables that are stored in the contract storage. So if we have state variables, if you are directly interacting with the state variable, for example, inside the loops, trying to read from them continuously, or doing these kind of interactions with them, what would happen is it counts for the gas costs or external function calls. How many function calls we should avoid making more smart contracts, and try to actually have one smart contract if that works, because that also affects the gas costs. But it also depends on the way, actually, what is our intention, what is the implementation, what is the requirement of our project, and those kind of things really are there. So then there are loops. So execution of loops can be very expensive. We have to keep track of how to we minimize the loops on the iterations in a function, or iterations what we need to do. So for example, if you talk about the practices that are inexpensive or do not increase the gases, like reading constants or immutable variables, like I would say local variables, or like reading and writing memory variables like memory arrays or memory structs. Or if you have internal function calls, they are inexpensive, they are like free. So if we do that, so for example, if we go here, like I have a function here, for example, count my array. So I have a loop here, which is a state read. For example, my array is a state variable, so I'm reading it, so which is a state read. And then there is a my counter, for example, another variable, which is a state read again. So what happens is I am, continuously trying to read it in a array, in a loop. So what would happen? This is quite expensive to perform write the code in this way for the smart contracts. However, instead what we could do is, if we define a local variable like 256, or we have array length, for example, and we assign it my array dot length, okay, like there below. So we could say this is a one state read, right here, one state read. So the next thing is, instead of this, I'm writing, okay, array underscore length, which is not a state read, which would be a local read, okay. And next is my counter. So here, if I talk about my counter here, for example, what I do is instead I declare another variable like 256, or I would say local counter underscore CTR. So I'll assign it to my CTR, like for example, my CTR. So this is another second state read, right? State read, for example. So, but what I do here instead is instead of that, I'll be incrementing local underscore CTR. So upon completion of the loop, I could assign it back. So my CTR is equal to local underscore CTR. Okay. So this is another state read, second state, third state read. So see this practice, what happens is how many of these local reads, again, we are saving the gas here by doing this kind of practicing like this, writing code like this, using the local variables instead of the, you know, those state variables and all that. So these kind of practices are quite good, actually. So yes. So if we could, for example, for the external function calls, if we could just write a one contract that has the functionality that is required, that is better. However, if the structure or the is does not allow us, we need to create, for example, another these you know, smart contracts. Like for example, there's a limitation to the amount of code that can be in a single smart contract. There's a limitation to that. We cannot even we cannot exceed that. There is also a problem. So in that case, we cannot avoid always the, we cannot completely make the gas zero, but we can try to make it, in our way, try to make our codes more efficient that way. So that's why the practices should be very clean and good. So next, I would say like optimizing variables. So variable packaging. So I would say that, for example, if we talk about variable packaging, Solidity smart contracts, what they have is they have a contiguous 32 bytes of memory. So that would mean a single slot of 32 bytes, that is like 256 bit memory. So the way we declare the variables, for example, they'll be placed in that way because the memory is contiguous. So in that way, also we can save how we want to that, but it depends on the implementation. For example, I have here already kept here, like in order to save this time. So for example, you int 1 to 8, for example, we have first variable. Then I put the uint 256 third variable, for example, uint 1 to 8. So first we have first contiguous block is 256, right? 256 bits. But there we are putting the first one, that is 1 to 8 bit. So that one, what happens is the half of it is already empty, for example. So then we have another contiguous block, which is 256, which is filled. Then we have another 1 to 8, which is again, half. So how we can optimize this, how packaging variables can be done. For example, if we are declaring a variable like this, and we are putting it this way instead. So what happens is 128 fit in the same slot, then same slot of memory, and 256 after that. So this is quite efficient, but however, it is not necessary that we might require what you call that the variable has to be 128, it might overflow. So in that case, what I think is it depends on what is the implementation, what is the variable you're declaring for, what kind of information it will be storing. So in that sense, yes, I think that is important. So now if you talk about initialization, if I talk about initialization, so declaring a variable is way cheaper then declaring and initializing at the same time. For example, you have a into 5 6, for example, a if I just declare it, it's cheaper than if I put like into 5 6 is equal to 0. So that is also one of the practices. Well, here is a bonus point we are coming to, which is deletion. So what is deletion? So basically, Ethereum gives you a refund on deleting a variable because you are removing the memory from the blockchain. So if you're deleting a variable, sometimes the refund is amounts to like half of the transaction fees. So I think this practice also needs to be incorporated, or if you are trying to delete a memory from the smart contracts itself. Fourth point here is storing data in events. So why do we store data in events? So the thing is, sometimes you're getting the data from for interactions from the smart contracts, or there's a value we are getting, but we it's a temporary value, or that we don't need to store, we just need to show once. So in that scenario, you can just emit that for to an event, and just that we do not need to save that. So this practice also lets us not increase the gas itself. So also, the other thing we should always do upon deployment, not during the development, I think, because the optimization, it might be a bit faster. So less amount of memory, less amount of bytecode is generated, like efficient bytecode. I mean, say is generated for Solidity gas optimizer. So how do you optimize, enable the Solidity gas optimizer? We do it in a truffle framework. In the config file, truffle config file, what we do is we have solc in the optimizer, we enable it to true. So if we follow those practices, they are gonna help us, become like efficient in terms of helping us in terms of implementing our code, our contracts, and making it easy for us. So thank you guys. This was all for this week. So next week I'm gonna come up with a new topic regarding the best practices in smart contracts. And until then, take care.